Okay, welcome back. So what we're going to do now is we're going to look at what happens when you know the gradient, but you don't know the angle of elevation. How do we calculate that? So what we have previously spoken about is that the tangent of an angle of theta is equal to the rise over the run. Okay, and remember that rise over run is the gradient. So if you're given either both the rise and the run, or the gradient, or the grade, then you can calculate the angle. Okay, we're going to go through how to do that now. I just want to go back to a few things first. Firstly, I want to talk to you about inverse operations. Okay, so inverse operations. We're going to just briefly discuss that first. Now, inverse is kind of similar to reverse, okay? It's not quite, but it's close enough. So when we're talking about inverse operations, it's like the opposite operations. And you learned about this when you were solving equations for the first time. The inverse of plus is minus, okay? So the opposite of adding is to subtract, okay? And that goes both ways. The opposite of subtract is to add. The inverse of multiply or times is to divide. Okay, now you've just learned about the tan operation, and when we have tan, we also have the opposite, the inverse, which is the inverse tan, and we write it like this. Okay, this is how we write inverse tan, and that's what we're going to be using today in order to solve this. So that was just a little bit of a backtrack to inverse operations so that you understand what this weird tan with the -1 above it is, okay? This literally means inverse tan. Inverse tan, okay? And that's what that's what I will call it through the videos, but that's really what it means, okay? It's like the opposite of doing tan. Now, let's say that we have a triangle, okay, because all you're learning about right now is triangles, and when you do trigonometry, which is what we're learning about right now, it's always with right angle triangles. You'll learn later other applications of it where you can use it in other forms of triangles. That will come in vwo3 if you do whisk and b, but that's not something we do at the moment in V3. So let's say that we have a triangle, we have our theta, and we have a rise of 4 centimeters, and we have a run of 8 centimeters. Okay. Now we are going to use the same formula that we had before. So we've got the tan of theta is equal to the rise over the run. Okay, that's what we said before. Tan of theta equals rise over run. Now, we don't know theta, so we're going to keep it as tan of theta is equal to, the rise is 4, and the run is 8. Now, you can change that to a half if you want. You can change it to 0.5 if you really want. We don't need to, okay? I typically wouldn't change things to a decimal. I've talked to you about this before. We don't use decimals very often because they're not accurate, especially in the middle of a question. You should never use a decimal in the middle of a question if you have an applicable fraction, so keep the fraction as it is, but a half would also be fine here. So we have the tan of theta equals 4 over 8. Now, thinking about these inverse operations, if we had, please don't write this, but if we had 1 plus the tan of theta, then to get rid of the 1, we would do -1 on both sides, okay? But we don't have 1 plus. What we have is tan. We want theta by itself. That's what we want. And at the moment, the tan operation is working on the theta. Now, to reverse tan, we need to do inverse tan. So we're going to inverse tan this, and that's going to give us just theta. Now, as usual, if you do something to one side, you have to do it to the other side. I'm going to move the 4/8 over a little bit because I don't really have space here. Oh, actually, maybe we'll just write it on the next line. Okay, it's probably easier. So normally I wouldn't write this line that we're about to write, okay? So we never write this. but this is more for you guys to see how it works here. So we have the tan of theta. Okay, and what we're going to do is we're going to do the inverse tan of this. Okay, so we're going to undo tan to be left with just theta. Okay, if we do inverse tan to that side, we also need to do inverse tan to the other side. 4/8 or a half, whatever. Okay, and as I said, we don't normally write this step. Okay, I only write it the first time I go through it so that you can see how it works. So once you do the inverse tan of tan theta, what we get left with is theta equals the inverse tan of 4/8. Okay, so again, pretend this line here doesn't exist. It's just good for you to have seen why we do the inverse tan of 4/8. Okay, so theta is the inverse tan of 4/8. Now, how to do this on your calculator? If you look at the tan button, so you see the tan button over here, and just above it, you will see tan minus 1, which is the inverse tan. We're going to use that. Now, you can see that the inverse tan is in yellow, and if you look in the top left corner of your Casio, of your calculator, you see a shift and an alpha. Shift is yellow, alpha is red. Now, to get to any of the yellow functions, you need to use shift. If you want to get to the red functions, then you need to use alpha. The inverse tan is in yellow, so we're going to use shift. So we're going to press shift. I might just clear what's already on the screen if I can work out how. Yep. Shift tan, and that gives us inverse tan. You can see the little -1 up here on the screen. So we have the inverse tan of 4 divided by 8. Okay, you could also use the fraction button. I'm going to use the fraction button on this one. Most of you don't have the calculator with the fraction button, but if you use your ABC button, it does the same thing. Okay, so you can use your ABC button. I just don't have that on the screen, unfortunately. So the inverse tan of 4/8, if you press equals, will give you this number here. So theta is equal to 26 point, let's round to 2 decimal places. So, need to change my pen. Theta is approximately equal to 26.57 degrees. Okay? What you will notice in your book is that usually in numbers and space, they round degrees to 1 decimal place. Okay, so in this case, actually what the book would do is they would say 26.6 degrees. That's also fine. Mostly you should check what the textbook or the question is asking you to do. But as usual, 2 decimal places is pretty much always fine unless you're told otherwise. Okay. One exception to that is if you do probability, then we usually use 3 decimals. And yeah, with angles, we quite often use 1. However, this really is just a choice that the book makes. It's not something that is a fast rule in the universe. Okay. Use whatever is given to you in the question or round to 2 decimal places. It's fine. Okay, so this is how we calculate an angle, okay, if you know the rise over the run. Now, I want to just do one more example where you don't know the rise over the run, but you might be given, okay, triangle ABC has a gradient of 0.23. What is the angle of elevation? Okay, and I'm going to include a picture of triangle ABC because it's not fair to do this if we don't know that it's definitely a right angle triangle. Because if it's not, we can't calculate this. So this is ABC, and it has a gradient of 0.23. Now, let's go back to what we know, which is the tan of theta is equal to the rise over the run. Now, don't forget the rise over the run is also equal to the gradient. Okay? So we know our gradient, so the gradient is 0.23. So what we're going to write here is the tan of theta is equal to 0.23. Okay, now we can just use our formula. Okay, so the tan of theta is 0.23. If we want to get theta by itself, we need the inverse tan of 0.23. Okay, that is all we're doing. So the inverse tan of 0.23, and as you can see, I skipped that extra step going through here because you don't need to write it, and please don't, it's completely unnecessary. Okay, you must write this step though, and this step, and also your formula in the beginning, because that's what we expect from you. So let's have a look at what that gives us. So we're going to type in here, let's clear it, the inverse tan of 0.23, close brackets, is equal to 12.95. So theta is approximately equal to 12.95, and don't forget this is degrees. Okay, so guys, this is how you calculate an angle of elevation when you know either the gradient or both the rise and the run. Okay.